Harbor will take over from there. What is functional anatomy? It is the subdiscipline concerned with understanding the anatomical basis of human movement and the effects of physical activity on the musculoskeletal system. Functional anatomy deals with the body's four major systems: the muscular system, the skeletal system, the respiratory system, and the circulatory system. All these systems working together in the body perform different functions, makes up functional anatomy. Components and subdisciplines. Examples of subdisciplines of the four major body systems. Now, we have the muscular system, the study of how the muscular system works and its functions would be myology. The skeletal system, we have osteology, and the respiratory system and the circulatory system, they work in conjunction together, would be pulmonology, and how they work together will be further explained here in the basic concepts of functional anatomy. The basic concepts of functional anatomy can be explained through the functions of the four major systems of the body. We have the muscular system here, myology. This produces movement, stabilizes joints, maintains posture, and generates heat during activity. We see that throughout our everyday lives. I mean, we always move our muscles, which requires our bodies to move. All of this is pretty much common knowledge here, as we know, but this right here generates heat during activity. This right here is pretty interesting. We experience this when we are cold. For the most part, a great example of this right here would be when our body shivers. That shivering of the muscles and that friction of that activity in our muscles helps generate body heat to try to help keep ourselves from freezing. Osteology in the skeletal system, we also have here support, movement, organ protection, blood cell production. And that works through our bone marrow, calcium storage, that too as well, and endocrine regulation. Pulmonology, that's study of our respiratory system, brings oxygen into the bloodstream to carry throughout the body and removes carbon dioxide waste. And in the circulatory system here, also, the study of pulmonology transports nutrients throughout the body. Now, these two systems work together, and with our respiratory system, bringing oxygen into the bloodstream, that's simply as we breathe in, as we inhale to bring oxygen into our body, that goes throughout the bloodstream and, goes throughout our body to give nutrients to our body. That also happens once we eat, we drink fluids and all of that, and that carries on into the circulatory system, how through our bloodstream those nutrients are carried throughout our body to help nourish our body. And in this part of here in the respiratory system, removes carbon dioxide waste. That's just the opposite of this right here. Simply as we exhale, our cells in our body, as they do what they do, the waste that is produced is carbon dioxide, and we simply get rid of that carbon dioxide by exhaling. After we inhale, we just simply exhale by getting rid of that carbon dioxide waste. It's a very simple process, but that simple process does a lot for us in these concepts here in the respiratory system and the circulatory system, as they both work together to do what we need our bodies to do under the study of pulmonology.
Okay, so I will cover the basic concept examples for functional anatomy. I'm going to start by talking about the different muscle types used. which are going to be the type 1 and type 2 fibers. So type 1 fibers are going to be the low force, high endurance activities such as a long run, long duration walk, something that doesn't require a lot of speed or force, just a lot of time. The type 2B or type 2X, sometimes it's called, is that which requires a high force and low endurance exercise. So that one would be a good example, like a sprint off the starting block, a long jump, something that's just a few quick seconds. That's a lot of force. And then that type 2A is going to be kind of in the middle of those. So your functional anatomy is going to come into play, like the previous slide you talked about with your different, the different components of the muscular system. This is one of those components. This is something that contributes to the overall functional anatomy of the body. And then we're going to talk about the types of joints. So your body has 6 different joint types. We have, we'll start with the plantar. The plantar joint allows for gliding movement along 2 flat bones. An example of that would be the hands and feet joints. Those are going to have very limited range of motion. Next you have the hinge joint. Good example of that is going to be your elbow. So in your hinge joint, it just allows just one range of motion. It's going to be bending back and forth. And then you have your pivot joints. Those pivot joints are going to be those that allow for rotational movement. And a good example of that one is going to be the first and second vertebrae in your neck, which allow you to rotate side to side with your neck. And then you have the condyloid bones, which allow a range of motion with angular movements. A good example of those would be your wrist. So it allows side to side and up and down movements, pretty good range of motion. But that next one, the saddle joint, is going to be one that allows even more range of motion. And then finally you have a ball and socket joint, which this one is the one that allows the greatest range of motion. Those are going to be your shoulder and hip joints. That one allows, rotation, up and down, side to side, kind of all of the different ranges of motion with that. Next, we have adaptations to training. We're going to talk about the effects that training has on bone, has on muscle structure and function, the tendinous adaptations, and then effects on joints and range of motion a little bit as well. So effects on bone. Not all effects on bone are positive. Maladaptation is possible if the training intensity is too much with not enough rest time or recovery time, especially with young athletes. That's why you see frequent stress fractures with the young generation. So generally, a lack of physical activity is going to result in a loss of bone mass, whereas an increase in the physical activity will increase your bone mass. A good example of this is going to be a research done on a tennis player. So they researched the humerus and against the dominant arm versus the non-dominant arm of that tennis player. In their research, they found that the dominant arm had denser bone, stronger and more compact tissue, and a longer bone shaft on the humerus than the non-dominant arm did. Effects on muscle structure and function. So you're going to have hypertrophy and neural adaptations. Now, hypertrophy is obviously going to be an increase in muscle size and strength. But before you have hypertrophy, you have neural adaptations, which are going to be the brain and neurons firing in the correct order and sequence to call on those muscle fibers from the last slide, the type 1 and 2A ones. So your neural adaptations are going to be responsible for the initial strength gains, and then after that, it'll be true hypertrophy or true increase in strength of the muscle. And then you have the tendinous adaptations. So an article I read about this one says that with physical activity comes an increase in tendon stiffness. Now this term stiffness describes a mechanical property of the tendon. Force requires this stiffness to stretch the tendon. So an increase in the tendon stiffness impacts the ability of the muscle to generate force in movements that the body needs. And then you have the effects on joints and range of motion. So chronic exercise is going to have that cartilage work around a little bit more, absorb more of the synovial fluid, and become thicker, which is more beneficial for bracing like the force of activities. And then flexibility. So flexibility is dependent more so on the tendon and muscles that run across the joint rather than the joint itself. But an increase in flexibility comes along with training, and when you have an increased flexibility, you have a greater range of motion in joints that allows more movement freely with less risk of injury. And then finally, we have how functional anatomy interacts with other subdisciplines. Now, this picture is a little bit hard to see, but down here at the bottom, you see that you have the subdisciplines, and the first one we have is the functional anatomy. And you can see that functional anatomy is tied into anatomy and physiology. Now, among these ones here at the bottom, the ones that also tie into the same parent disciplines as functional anatomy done is going to be biomechanics, exercise physiology, and then motor control. All four of these have some concept of anatomy and physiology in them. They all tie in together. Exercise physiology ties into functional anatomy, so does biomechanics. Functional anatomy ties into motor control, and they all really just mesh together and require a basic understanding of anatomy and physiology. And then here are our references that we used, and then I'll have the questions posted on a separate document with that as well.